As we go through the notes for Unit 8, Learning Target number 3, you need to make sure that you're writing all of the information down in your notebooks unless otherwise noted. Okay, this first slide, you need to make sure you title your notes Unit 8, Learning Target number 3. We are going to be talking about polygons, and this learning target is on your learning target sheet as well, so you don't need to write all this down. You do need to write this information down. Polygons comes from the Greek word for many. Okay, a polygon is flat, 2 dimensions. And this is really important, what I've circled in blue. The number of angles always equals the number of sides. And go ahead and write down some of these examples here. Another important characteristic, each vertex of a polygon is the endpoint of 2 line segments. So what I mean by that is, here I've got a vertex connected by 2 line segments right here. Okay, over here I've got a vertex. There are 2 line segments that are connected to it. So a polygon with 4 sides is called a quadrilateral. Polygon with 3 sides is called a triangle. So you need to make sure you have this written down, and then when you're finished, you need to turn in your packet to a paper that says, I believe it says concept map on it. So you're going to turn to the concept map, and it's going to look very similar to the one that I'm going to pull up here. So you have a concept map that looks pretty similar to this one. A quadrilateral, it must have 4 sides. Okay, but a quadrilateral can be broken up into 2 other parts, parallelograms or trapezoids. So if you remember when we talked about the real number system, rational and irrational numbers, this trapezoid right here, this is out there by itself. It's kind of like those irrational numbers. Where rational numbers, they had subgroups. Same thing here. A parallelogram has different subgroups. Okay, it's always going to work from the bottom up. So example, all squares are rectangles, but not all rectangles are going to be squares. All squares are going to be rhombus, but not all rhombuses are going to be squares. Okay, all parallelograms are going to be quadrilaterals, but not all quadrilaterals will be parallelograms. So do not lose this concept map that you have. At a later time, I would write down these definitions in your notes so that you have them. Okay, another type of map you could notice here is with this Venn diagram. A square is in the center because a square is a rhombus and it is a rectangle. But not all rectangles are going to be squares, and not all rhombuses are going to be squares as well. So you can write this one down if maybe this appeals to you more. Okay, you do need to write this down to remind you. All squares are rectangles, not all rectangles are squares. All rectangles are parallelograms, not all parallelograms are squares. So if you look at that concept map, that should make sense. Okay, you need to be able to answer true or false type of questions like this for your assessment. So make sure you have this written down. Okay, we need to be writing down this criteria as well. For a polygon must be a flat 2-dimensional shape. So if you notice this one that I crossed off, this is not 2 dimensions, so it is not a polygon. Second one, must be made of 3 or more line segments. Nothing can be rounded. So this would not be a polygon. This one here is a polygon. Polygon is not allowed to have any openings or gaps. So this one here is not a polygon. This one here would be a polygon. So we need to make sure we have all of this information written down. You should have the examples written down before moving on. Another characteristic to note is that the line segments must not cross over each other. So this example on the right is not a polygon. The one on the left is. Okay, the line segments must only meet at the vertices, which make up the corners of the shapes. So for example, I've got a vertex here, I've got a vertex here, got a vertex here. However, on this first one, my vertices are right here, here, and here. So this one in the center does not meet at a vertex, therefore it is not a polygon. This third one would not be a polygon because the line segments only meet at the vertices. Okay, right here that keeps going. It's not closed, so it is not a polygon. So we can go ahead and cross that one off as well. This page you do not need to write down, but let's just recall some polygons that I know you have learned about in the past. Triangles, quadrilaterals, which we talked about today, pentagon, hexagon. So you may write these down, but you do not need to. But we will be referring back to these. Okay, you want to make sure you write down the definitions of these polygons: octagon, a decagon, a hexagon, and a pentagon. So pause the video and write these down before moving on. These are all examples of polygons. We also are going to talk about regular polygons. All angles are going to be congruent. Another word for this is equiangular. Congruent angles. All angles will be the same. And all sides will be congruent, which is an equilateral. So if you look at the first example, all of these sides are congruent, which is why I have one line to symbolize that they're all congruent. And all of the angles are going to be congruent. So this arc around each of them represents that all of them are congruent. However, in the second one, not all angles and sides are going to be congruent, nor will in this third one. So it is not a regular polygon. It is a polygon, but it is not a regular polygon. So make sure you have this page written down and your examples written down as well. In these three examples, we're just going to practice marking congruent sides and angles. So make sure you have the polygons written down. Okay, in the first example, these two red lines represent that those two sides are going to be congruent. Same with the little arches around the angles there on the triangle. Those angles are going to be congruent. In the second one on the right, those green lines represent that all of the sides are congruent. But if you look, there is one arch around the top two. So this one here and this one. Okay, that means those angles are congruent. However, if you look at the side two angles, there are two arches around those, and that's to represent that those angles are congruent, but they're going to be different from the other two. Okay, again in the last one, we've got two lines on the side representing here congruent and congruent, but over here we just have one line, so those two sides are going to be congruent. Again, we've got the arches and the angles, so that represents that all four angles are going to be congruent. Make sure you have this written down before moving. Okay, last,